Everyone, this is Anurag Tiwari, roll number 10142, and today we are going to study about biostabilization
and stability factors. So coming to stabilization. Stabilization is basically the process of making operating point independent of temperature changes and variation in transistor parameters, which means that the operating point, which is basically the VCE and IC, will not depend on temperature and transistor parameters. So now coming to the causes of unstabilization. So basically the Q point will shift, which means that the IC will increase or decrease depending on two factors. First, the change in beta, which is basically the current gain, and second, change in temperature. As we can see that if temperature increases, the current ICB will also increase. So basically the IC will increase if ICBO increases. Now coming to stability factor. Stability factor is the rate of change of collector current with respect to leakage current at constant input voltage and amplification factor, which is basically the beta, and input voltage is VBE. So stability equal to differentiation of DIC by DICBO at constant voltage VBE and beta. If the value of stability factor is very less, which means it is more stable. Now coming to S prime, which is equal to DIC by DVBE at constant ICBO and beta. Now let's find out the stability factor for different kind of biasing circuits. Now coming to fixed bias circuits. Fixed bias configuration. So step 1, which is applying KVL in input loop. Now applying KVL in input loop, which will give VCC, basically in this loop, will give VCC minus IBRB minus VBE, which will comes to 0, and IB equal to VCC minus VBE by RB. This is equation number 1. Now step 2, calculating IC. So basically the formula of IC is beta IB plus beta plus 1 ICBO. Now putting the value of IB in this equation, we can get that IC equal to beta VCC minus VBE by RB plus beta plus 1 ICBO. This is equation number 2. Now coming to last and final step, which is differentiating equation number 2 with respect to IC, which is collector current. So stability equal to DIC by DICBO at constant VBE and beta. In equation number 2, VBE and beta is constant and VCC and RB are also constant. So differentiation of IC by differentiation of IC equal to beta by RB d VCC minus VBE by DIC plus beta plus 1 DICBO by DIC. So basically this factor, this is reciprocal of stability factor 1 by S. We can replace this as 1 by S. And coming to VCC minus VBE, which is, as we can see that VCC and VBE both are constant. So the differentiation of this factor remains 0. So we can, this is also 1 equal to beta by RB 0 minus 0 plus beta plus 1 and 1 by S. So from this we can see that stability factor is equal to beta plus 1. This is the stability of fixed bias circuit. Now we will derive for emitter bias circuit. So step 1 is applying KVL in input loop. So applying KVL, VCC minus IBRB minus VBE minus IERE equal to 0. So from this we can see that IB equal to VCC minus VBE minus IC RE by RB plus RE, because IE is nearly equal to IC and IC, because IE equal to IC plus IB. So step 2 is basically IC equal to beta IB plus beta plus 1 ICBO. So we can put the value of IB in this equation. And coming to step 3, which is the final step, which is stability equal to DIC by DICBO. So DIC by DIC equal to beta by RB plus RE D by DIC VCC minus VBE minus IC RE plus beta plus 1 differentiation of ICBO by IC. So 1 equal to beta by RB plus RE. Rest of the factors are 0, 0 as they are constant, getting only RE plus beta plus 1 and the reciprocal, which is S. So 1 equal to minus beta RE by RB plus RE plus beta plus 1 by S. So on further solving, we can get S equal to beta plus 1 by RB plus RE by RB plus beta plus 1 RE. This is the formula of stability factor for emitter bias configuration. ये वाला पार्ट हटा देंगे। नहीं चल रहा, हम उसमें बीच से हटा देंगे।
थोड़ा लैपटॉप पे या फिर फोन में हो जाएगा तो कितना बचा है?
सिर्फ कलेक्टर फीडबैक करेंगे, वोल्टेज डिवाइडर नहीं करेंगे। नाउ कमिंग टू द फाइनल नंबर 3, कलेक्टर फीडबैक. Collector feedback biasing. Now step 1, applying KVL in input loop, we can get VCC minus IC plus IB RC minus VBE minus IB RB equal to 0, in which we can get IB equal to VCC minus VBE minus IC RC by RB plus RC. Step 2, substituting value of IB in the equation of IC, we can get beta equal to IB plus beta plus 1 ICBO. And the final step, step 3, which is basically differentiation of IC with respect to DIC, which will give DIC by DIC equal to beta by RB plus RC. And when we can differentiate this all remains 0, and differentiation of IC with respect to IC will give 1, and differentiation of RC, which will give you only RC, basically minus RC, plus beta plus 1 ICBO by differentiation of IC. So this factor is 1, so 1 equal to minus beta RC by RB plus RC plus beta plus 1 by S. So on solving this here, stability equal to beta plus 1 RB plus RC by RB plus RC beta plus 1. So these are the formula for stability factors of different types of biasing. Hope you understand from this video. Thank you.